SpaceX just stacked Booster 19 for Flight 12. Now, if you've been following Starship, you know this should be routine by now. Except, it's not. This booster is packing Raptor 3 engines, 280 tons of thrust each. That's 20% more power than anything we've seen on Starship before. But here's the part nobody's talking about. 3 weeks ago, Booster 18 straight up collapsed during a pressure test. Total structural failure. The kind of failure that used to kill programs for months. So how is Flight 12 already this close to launch? And what does that tell us about where this whole thing is actually going? Let's find out on today's episode of New Space Review. Okay, so we need to rewind to late 2025. Boca Chica. Booster 18 is on the pad going through a standard pressure test. They're filling it with cryopropellants, simulating what happens during an actual launch. Everything's going fine until it's not. The methane tank just gives out. We're not talking about a minor leak here. The tank walls buckled. The whole structure started caving in on itself. When that happens, you're done. There's no fixing a primary tank failure. You can't weld it back together and call it good. The vehicle's compromised. So SpaceX looked at it, ran the numbers, and made a call. Scrap it. Move on. And honestly, that tells you where the program is right now. A few years back, losing a booster like that would have been a 6-month setback, minimum. This time, it barely slowed them down. Because Booster 19 was already in production. They just shifted focus, wrapped up the build, and stacked it. That's the thing people don't always get about how SpaceX works. They're not betting everything on one vehicle. They've got multiple boosters and ships in various stages of assembly at any given time. So, when one fails, the next one steps up. NASA would have launched a full investigation, design reviews, the whole 9 yards. SpaceX ran the failure analysis and kept building. That's the difference. Now, Booster 19 isn't just the next one in line. This is version 3 hardware, and version 3 is where things shift. Flights 1 through 11? Those were about proving concepts. Can we land the booster? Can the ship survive re-entry? Can we catch it with the chopstick arms? All of that was necessary, but it was still R&D. Flight 12 is different. This is SpaceX starting to treat Starship like an actual operational system. Let's talk Raptor 3 for a second. Raptor 2 puts out about 230 tons of thrust. Raptor 3? 280 tons. That's a huge jump. You're multiplying that across 33 engines, so you're talking millions of tons of extra thrust at liftoff. But it's not just about raw power. Think about what's happening in the first minute after launch. Starship weighs over 5,000 tons fully fueled. It's fighting gravity, drag, and max Q all at the same time. More thrust gives you margin. If an engine drops out, you've got backup. You accelerate faster through the thick atmosphere, which means less fuel wasted fighting gravity. And you can carry heavier payloads, 150, maybe 200 tons to orbit. That's the kind of mass you need for serious Mars missions. But here's what actually impresses me about Raptor 3. It's not just more powerful, it's cleaner. Raptor 2 had all this plumbing on the outside. Fuel lines, oxidizer feeds, sensor cables, all exposed. During a 33-engine ignition, you've got insane vibration and thermal stress. Things expand, contract, shake loose. Those external lines were weak points. Raptor 3 moves most of that inside the engine structure. Fewer external parts means fewer failure modes. It's just smarter design. And then there's chamber pressure. Raptor 2 already ran at about 300 bar, the highest of any rocket engine that's flown. Raptor 3 pushes that even higher. Why does that matter? Because higher pressure means better efficiency. You get more complete combustion, better specific impulse. For Mars, every percentage point of efficiency you gain translates to hundreds of tons less fuel you need. That's the difference between a mission that barely works and one with actual margin for problems. Ship 39 is sitting on top of Booster 19. Earlier ships were focused on survival, testing heat shields, re-entry profiles, landing flips. Ship 39 is built for orbital operations. We're talking extended time in space, precise burns, maybe even refueling tests. Version 3 ships carry more propellant, better thermal protection, upgraded avionics. This is hardware designed to actually do something, not just prove it can be done. But stacking doesn't mean they're ready to fly. That's actually where the hardest testing starts. First up, cryo-proof tests. They load both stages with liquid oxygen and methane at their actual operating temperatures. Minus 183 Celsius for LOX, minus 161 for methane. Materials act completely different at those temps. Welds that look perfect at room temperature can crack under cryo stress. If anything looks off, the vehicle doesn't launch. Then comes static fire. This is wild. They clamp the fully stacked rocket to the pad, load it with propellant, and light up all 33 Raptors while holding it down. You're talking tens of millions of newtons of thrust, with the rocket going nowhere. The mount has to absorb all that force. The engines have to run stable. The structure has to handle acoustic energy that can literally shake hardware apart. If it passes static fire, it's ready. SpaceX usually runs cryo tests, analyzes data, then does static fire a week or two later. Based on that schedule, late January or early February for Flight 12 makes sense. Even if things take longer, we're talking weeks, not months. That's how much they've compressed the timeline. And Musk? He's not even waiting to see how version 3 performs. He's already talking version 4. Current Starship is about 120 meters tall. Version 4 will hit 140 meters, most of that going into the ship. Why? Propellant capacity. Version 3 holds around 1,600 tons. Version 4 will pack close to 2,300 tons. That's 50% more fuel. For Mars, that's everything. Version 3 can get you there, but the trip takes 6 to 8 months. With version 4's fuel load, you can run a faster trajectory, 3 to 5 months depending on the launch window. Cutting even 2 months off that journey reduces radiation exposure and life support needs by a massive amount. That's what makes crewed missions actually feasible. More fuel means more engines. Version 4 ship will probably run 9 Raptor 3s instead of 6. That gives you way more capability for maneuvers, corrections, and landing burns. But more fuel and engines means more mass, which means the booster has to scale up too. Version 4's Super Heavy will likely hold around 4,500 tons of propellant and run over 30 Raptors. Total liftoff thrust could hit 10,000 tons. For context, Saturn V was about 3,400 tons. Starship version 4 would be triple that. This is what sets SpaceX apart. They're not building one rocket and refining it for decades. They're treating it like software. Rapid iteration, parallel development. Version 3's getting tested. Version 4's being designed. Version 5's probably already getting sketched out somewhere. That pace is unprecedented, and it's why they're hitting targets that seemed impossible 5 years ago. So here's where we're at. A booster fails in December. By early January, the next one's stacked and moving toward launch. Raptor 3 isn't just an upgrade, it's changing what's possible for Mars. Version 4's already in the works with 3 times the power of Saturn V. This isn't careful, methodical progress. This is SpaceX turning decades of aerospace development into months. Flight 12 is coming, late January, maybe February. And when it launches, we're not watching another test. We're watching Starship transition from experimental to operational. That changes the whole timeline for Mars. If this breakdown helped, hit that like button and subscribe to New Space Review. Comment below, do you think they can keep this pace, or are they gonna hit a wall? Share this with anyone following space, and check out the video on screen. It's mind-blowing. Raptor 3 upgrade shocked NASA. 280 tons changed Mars. There's even more on what makes these engines special. Thanks for watching. See you next time.